Hello everyone. Today, let's continue our third section of doing the last year final exam. So the next part is question number 13, which is a simplified form of the expression cosec x plus cot x times cos x minus 1 in its domain, the simplified form. So let's simplify it. Cosec x, sorry, cosec x cosec x plus cot x times cos x minus 1, the simplified form of this one. So which is the same as, which cosec x means that 1 over sine x plus cot x means cos x over sine x. Sine x times cos x minus 1. Cos x minus 1. So taking sine x as common from the denominator, sine x, or taking sine x as common, we have this, then we'll get 1 plus cos x. 1 plus cos x. 1 plus cos x. Then, which is times this number, which is cos x minus 1. Cos x minus 1. So which is 1 plus cos x times cos x minus 1 when you are multiplying it, which is just cos x, which gives 1 times cos x, which is cos x, 1 times minus 1, which is minus 1, cos x times cos x, which is cos square x, cos square x, and cos x times minus 1, which is cos x minus cos x over sine x, over sine x. So cancelling this one by this one is cancelled, which means cos x minus cos x is 0. So what's left is cos square x, cos square x minus 1 over sine x. What's cos square x minus 1? So we know that sine square x minus plus cos square x is equal to 1. Which means that sine square x is equal to what? Is equal to 1 minus cos square x. 1 minus cos square x. Well, we have given here cos square x minus 1. Therefore, which is the negative of this one, Therefore, we get minus sine square x minus sine square x over sine x, minus sine square x over sine x. We get minus sine square x over sine x. So cancelling sine by sine, what's left is minus sine x. minus sine x is left, minus sine x is left. Therefore, the simplified form of this one is minus sine x, which is alternative B from the choice minus sine x. The other one, the solution set for the equation ln x minus 1 plus ln x plus is equal to 6, the solution set. So we know that ln A plus ln B is what? Ln A plus ln B can be written as ln A plus ln B can be written as ln A times B, ln A times B. So we can use this property of ln. Then ln x minus 1 ln x minus 1 plus ln x ln x is equal to 6 is given. Ln 6 is given. Therefore, ln x plus 1 plus ln x minus 1 plus ln x minus 1 plus ln x is which just which can we can write ln ln x plus 1 times sorry ln x minus 1 times x is equal to ln 6, which is ln 6. So removing ln on both sides, we get or x using a natural exponential function, we get x minus 1, which is x minus 1 times x minus 1 times x, which is equal to 6, which implies that, which is the same as x squared minus x squared minus x minus 6 is equal to minus 6, which is equal to 0, So which is the same as when we multiply two numbers, their product is minus 6 and their sign is minus 2. Therefore, x minus 3 times x plus 2, x plus 2 are the two numbers. Therefore, x minus 3, which is equal to 0. So the value of x is x is equal to 3, or x is equal to minus 2. Clearly, from the domain of exponential function, x is equal to minus 2 is not an element. Therefore, the only solution is x is equal to 3. X is equal to 3 is the only solution. So x is equal to 3 from the set of alternative. This one is the solution. And the domain of the function f of x is equal to x squared plus log 1 minus x squared plus log 1 minus x. So the domain of x, we have two functions here. F of x has two functions. F of x is equal to g of x plus h of x, which is equal to, which is g of x, which implies g of x is x squared. G of x is equal to x squared, which x squared is the first function, which is the domain of this function. The domain of this function is all real number. The domain of this function is all real number. The domain is all real number. What about the domain of h of x? The domain of h of x, domain of h of x is h of x is log 1 minus x, log 1 minus x. So we can write the logarithmic of h of x, so log 1 minus x is just a common logarithm. We can represent this one, which is just common logarithm, which is just base 10. Therefore, we can write just y, which is equal to log 1 minus x in base 10. 1 minus x in base 10. 1 minus x in base 10. So we can write this one just like this one. 10 the power of y, 10 the power of y, which is equal to 1 minus x. 10 the power of y, which is equal to 1 minus x. So when y is equal to 0, we have this one. When y is equal to 0, it becomes 1, which is equal to 1 minus x. Therefore, x implies when y is equal to x becomes 0. So which is the x-intercept and y-intercept. 0, 0 is the x-intercept and the y-intercept. The other one, which is when we are drawing this one, we have 0, 0 here, the x-intercept and y-intercept, and the other one is what is the vertical asymptote for this logarithm function. So as y moves to infinity, as y moves to infinity, x moves to infinity. As y moves to infinity, you can see that x moves to negative infinity. X moves to negative infinity. X moves to the negative infinity. And the other one is as y moves to negative infinity. As y moves to negative infinity, x moves to this one. As y moves to negative infinity, this part becomes 0 and x moves to 1. Therefore, we have obtained this constant number, which is x is equal to 1 is vertical asymptote. Therefore, as y moves to infinity, as y moves to negative infinity, x moves to this. So just like this one, which is log 1 minus x, log 1 minus. So the domain for this function is minus infinity up to 1, which is an open interval 1. And the intersection with this ordinary number, the intersection with ordinary number, the domain of G, which is this one. So minus infinity up to 1 is the domain. Minus infinity up to 1 is the domain for this logarithm function. So this is the solution. The other one is the mapping f, which maps from x to y, is said to be 1 to 1. Said to be 1 to 1. A function is said to be 1 to 1. We have defined this one in the first session of this exam. A function is said to be 1 to 1 if every element in the domain should map to a single element in the range. Should map to a single element in the range, or we can say that no element in the domain should map to two different elements in the range. No element in the domain should map to two elements in the range. And the definition says that if the definition says if f of x1 is equal to, if f of x1 is equal to f of x2, if f of x1 is equal to f of x2, then x1, which then x1 is equal to x1 is equal to x2. This is the definition for every x1 and x2 in the domain. For every x1 and x2 in the domain, it satisfies this condition. But this definition can be written with which is equivalent, which is a logical statement, which is a conditional statement. So we can write the contrapositive of this statement. So what's the contrapositive of this statement is if x1 is different from x2 in the domain, if x1 is different from x2 in the domain, then f of x1 is different from f of x2. So which are those two are the definition for a one-to-one function. Therefore, from the set of probability, if x1 different from this, then f of x1 is different from for all x1, which is the first point. If f of x1 is equal to f of x2, then x1 is equal to x2, which is for all x1 and x2. F of x1 is equal to f of x for all x1. No. So f of x1, so the choice for A and B are the correct solutions. A and B are the correct solutions. The other one is consider the function g of x is equal to the square root of x minus 1 and h of x is equal to x squared minus 1, the composite function h of g of x. H of h of g of x, h of g of x, g of x can be written in such a way. H of g of x can be written this one, which is h of x is clearly x squared minus 1. So h of g of x can be written as h of g of x can be written as, we can write just like this one, which is g of x, g of x squared, g of x squared, g of x squared plus 1 plus 1. So which is the same as g of x squared plus 1, which is g of x is this one. So square root of x minus 1, x minus 1, x minus 1, the whole square plus 1 plus 1. So which is the same as x minus 1, which is the same as x minus 1 plus 1, x minus 1 plus 1. So what's left is x is left. So the composite function of g of x is the only function x. So B is the alternative. B is the alternative. Let R be the relation undefined, which is on the natural number. Then R is of this one, 1 plus x and 1 plus x squared, where x is less than 5, less than or equal to 5. X, which one of the following is not true about the relation R? So let's find R first. What are the R elements? What are the R elements? What are the R elements? So x is less than or equal to 1. So the domain elements are 1, 2, 1, 2, 3, 3, 4, 4, 5, 5. These are the domain elements. Therefore, which one is the true? Which one is not true? Which one is not true? So when x is equal to 1, which is 2, 2, and here is which is 2, 2, 2, and the one when x is equal to 2, which is 1 plus 2 is 3, 3, and which is 5, to square is 4, plus 1, 5. When x is equal to 3, when x is equal to 3, so when x is equal to 3, 1 plus 3 is 4, 4, and 3, which is 4, 1 plus 9 is 10, 1 plus 9, 10. When x is equal to 5, when x is equal to 4, 1 plus 4 is 5, 5, 5, 4 is 16, which is 17, 17, and the last element, when x is equal to 5, which is 6, 6, and 5 square, which is 25, which is 20, 20, 25, and 10, 6, 16, 6. So these are the elements. These are the elements. So the relation R is 2, 3, 4, 10, 5, 17, 6, 25, 6, 25. It's not 6, 25, it's not 10, 6 instead. R is a function, clearly it's a function, true. R is one-to-one function, clearly it's a one-to-one function because a one-to-one function, every element is mapped to a unique element in the range. All of the above and then. So which one is not true? Not true is the first question, A. A is the solution. The other question is relation R is given from, which is defined from on the set of natural number, which is defined by x, y, so 2x plus y is equal to 8. Then the range of sorry, the domain of this relation. The domain of this relation is, which one is the domain of this relation? The domain of this relation. Sorry, doing this one. Not this one. The domain of this relation is what is the domain of this relation? So now we can do this one. So 2x plus y, 2x plus y, which is equal to 8, which is equal to 8, which is equal to 8. So y is the same as 8 minus 2x. 8 minus 2x. Y is the same as 8 minus 2x. Now we can substitute the value of x from starting from 1, 2, 3. Then, so when x is equal to 1, what will be the value of y? When x is equal to 1, y is equal to 6, which is a natural number, clearly true. which is a relation R. The relation R contains those elements. When x is equal to 2, when x is equal to 2, which is 8 minus 4, which is 4, it's another element. When 8 is equal to, when x is equal to 3, when x is equal to 3, when x is equal to 3, 3 which is 6, which is 2, which is 2. When x is equal to, when x is equal to, when x is equal to 4, when x is equal to 4, when x is equal to 4, which is 8 minus 8, which is 0. And when x is equal to 5, 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 it becomes 8 minus 10, which is minus 2. But minus 2 is not an element in the set of natural numbers, which is not an element in the set of natural numbers. Therefore, this element is not on the relation R. So the only elements in the relation are 1, 6, 2, 4, 3, 2, and 4, 0, 4, 0. So the domain of these elements 1, 4, 1, 2, 3, and 4. 1, 2, 3, and 4. Question choice 3 is the solution. The solution. The other one is the contrapositive. The contrapositive of the preposition. If the weather is cool, if the weather is cold, then Enoch dislike playing football. So the contrapositive is, so if the contrapositive of the preposition P implies Q, P implies Q. The contrapositive of P implies Q. The contrapositive of P implies Q is, the contrapositive of P implies Q is negation Q. Negation Q implies negation P. Negation Q implies negation P is the contrapositive. I think in the first chapter of your course, we have learned about the converse, inverse, and the contrapositive. The converse, inverse, and the contrapositive. The converse of P plus Q is just Q plus P, and the inverse is negation of P plus negation of Q. Then the converse of the inverse gives the contrapositive of this statement. Converse of an inverse. The converse of an inverse gives this preposition. This preposition. So the contrapositive for P plus Q, the contrapositive for P plus Q is negation Q implies negation P. Negation Q implies negation P. So let's do using that definition. Let's do that using that definition. Let's do using that definition. So if the weather is cold, then Enoch dislikes playing football, which means that Enoch dislikes Enoch. If Enoch, negation of Enoch dislikes playing football, so P is, so we can write just P is, the weather is cold. The weather is cold. The weather is cold. Is cold. Is P, which is P, and Q is Enoch dislikes. Enoch. We can take the full statement. Enoch dislikes, but dislikes is just negation of like. Dislike, Enoch dislike. Enoch dislike. Enoch dislike. Enoch dislike. Enoch dislike playing football. Playing football. Dislike playing football. So, as we have said to you, we are asked to find the contrapositive. So to say something about the converse inverse of a conditional statement, we have given P implies Q. So Q implies P is the converse. Q implies P is the converse, which is the converse, which is the converse, and the inverse is negation of P. Negation of P implies negation of Q. The inverse is negation of P implies negation of Q. So the converse of an inverse, or the inverse of the converse, is the contrapositive, which is negation of Q implies negation of P, which is negation of Q implies, which is the inverse. Just to recap what we have learned about converse, inverse, and an inverse of a conditional statement. Converse, inverse, and inverse of a conditional statement. So from the state of alternative, negation of Q is Enoch like playing football, and the negation of weather is cold is weather is not cold. Weather is not cold. So if Enoch dislike playing, dislike it's not like, just we concentrate here. If Enoch like playing football, good, then the weather is not cold. If Enoch playing football, then the weather is cold. So the C is a good alternative. Exactly. If Enoch like playing football, then the weather is not cold is the exact solution, which is a contrapositive statement. So another question, let g of f of x is given this one, then g of x is equal to x plus 1, then f of x is what? So g of f of x is equal to, g of f of x is equal to, 2x squared minus 1, 2x squared minus 1, and g of x is given this one. So g of x is equal to, so g of x is equal to this one. So g of f of x is this one. G of f of x is equal to this one. G of f of x is 2 times f of x, 2 times f of x plus 1, 2 times f of x is equal to, which is equal to what? Which is equal to 2x squared minus 1, 2x squared minus 1. So which is the same as 2, which is the same as 2 f of x, 2 times f of x, 2 times f of x, which is equal to 2x squared minus 1 minus 1. So which is the same as, which is 2x squared minus 2, which is the same as taking 2 as common, 2x squared minus 1, 2x squared minus 1, 2x squared minus 1, 2x squared minus 1, 2 by 2 is cancelled. Therefore, f of x is equal to x squared minus 1, x squared minus 1 is the set from the set of alternative. D is the solution, x squared minus 1 to x squared, which is the solution. Therefore, f of x is obtained. One of the graph has a hole at x is equal to minus 1. How hole is formed? So hole will be formed by after cancelling the numerator and denominator. If the numerator and denominator are cancelled, then we obtain a hole, because we do not remove that, we do not consider that one when we are defining the drawing the graph of that function, and we should consider while we are defining, or we should exclude from the domain of the function. So f of x is equal to x minus 1 over x squared minus 1. So x minus 1 over x squared minus 1. X squared minus 1 is x plus 1 times x minus 1. So which is this one will be cancelled by this one. So which is what's left is x plus 1 is left. X plus 1 is left. Clearly, x is equal to 1 is a whole here. X is equal to 1 is a whole here. Here, x plus 1, question number B. Question choice B is x plus 1 over x plus 1 over, which is x plus 1, x plus 1, x plus 1 times x minus 1, x minus 1, x minus 1, 1, x plus 1 by x plus 1 is cancelled. What's left is 1 over x minus 1, 1 over x minus 1, but x is equal to minus 1 is a whole here. X is equal to minus 1 is a whole here, and x squared minus 1 over x plus 1, x squared minus 1 over x plus 1, and which is also the same. X squared minus 1 over x plus 1 is also the same. So the only solution for the graph is has a whole at x is equal to 1 is the first choice. The first choice. If cos x is equal to minus 1, and if cos theta, we can say cos theta. If cos theta is equal to minus 1 and pi over 2 less than theta less than pi, then the value of sine theta over 2, the value of sine theta over 2, the value of sine theta over 2. So clearly, cos theta, which is cos theta is negative just at this point, which is minus 1. Cos minus theta is minus 1 is here, which is at pi. Now, sine theta over 2, sine theta over 2, So which is, we can use double angle formula. Sine theta over 2 is, which is 1 minus cos theta. Is that 1 minus cos theta, 1 minus cos theta over 2, 1 minus cos theta over 2. So which is the same as 1 minus cos theta over 2, which is the same as square root of 1 minus minus 1, 1 minus minus 1, 1 minus minus 1, 1 minus minus 1 over 2. So which is 2 over 2, which is the square root of 2 over 2, which is the square root of 2 over 2, which is equal to 1, which is equal to 1, which is D is, from the set of matrix, D is the solution. D is the solution. D is the solution. And the last one is given p of x, which is f of x, is given p x cubed plus x squared minus 70x plus q, where p and q are constants. Suppose that given the function f of x by terms x minus 2 and x minus 1 leaves the same remainder, then what's the value of p? So when we are substituting the value to these terms, which means x minus 2 and x minus 1, then what would be the, which means when we are substituting 2, we get 8p, 8p, 8p plus 1 minus 70, plus 4 plus 34, plus 4 plus minus, which is when we are substituting to 34 plus q is equal to some k, some value of k, and when we are substituting p is equal to 1, when we are substituting p is equal to 1, we get p is equal to 1, we get p plus 1 minus 17 plus q is equal to k, So when we are simplifying this thing, we get 8p plus plus q, 8p plus q, and minus 4 minus 4 is minus 30 is equal to k, equal to k, is equal to k, and p plus q, p plus q, p plus q, p plus q, 1 minus 17 is minus 16, p plus q minus 16, which is equal to minus 16, which is equal to k, minus 16 is equal to k. So subtract from top to down. 8p minus p is 7p, 7p, 7p is equal 7p. 8q minus q is q, which is 0, and minus 30 plus 60, minus 30 plus 60, minus 40, minus 40, and k minus k is 0, k minus k is 0. So p is equal to, dividing by 7, p which is equal to how much? P which is equal to 2, p which is equal to 2 is the solution, p is equal to 2 is the solution, which is choice A is the solution for this one. I think we have finished the multiple choice part. Thank you for watching this video. Please share, subscribe my video, and please give me a comment. Please